Good evening, everyone. Welcome to our webinar on agentic AI using True AI. I am thrilled to take you on this journey into the fascinating world of agentic AI. Before we dive in, let me ask you a question. Have you ever imagined AI systems that can think, plan, and act independently, almost like a human team working together? Well, that's exactly what agentic AI are about. What is agentic AI and how we can create AI agents using free AI. This is the agenda for today. So we'll be learning about what is agentic AI, why agentic AI matters, key components, how it works, what is Crew AI, and some components that we are going to use in Crew AI. So what exactly is agentic AI? Agentic AI refers to AI systems that go beyond simply responding to commands. This is what it makes it different from traditional AI. These systems can sense, reason, act, and learn. They can sense, they can gather data from environment, they can process the information and decide what to do next. They can carry out decisions independently, and for the learning part, they can improve over time based on feedback. Agentic AI isn't about automation, it's about adaptability and problem solving. So, where it goes different from traditional AI. Traditional AI basically follows fixed instructions, and agentic AI thinks on its feet, adjusts to changing situations, and makes complex decisions. It's like the difference between a calculator and a personal assistant. A calculator can give you an answer when you type in numbers. A personal assistant, agentic AI, which is the agentic AI, can anticipate that you need a report, gather the data, format it, and adjust based on your preferences, all without asking you. The real-time examples of agentic AI can be like the GitHub Copilot that we use. These AI agents can debug code, suggest the next line, and automate repetitive tasks. They have boosted developer percent, which makes coding faster and more efficient. It's not just about writing code, they act as coding companions, suggesting solutions and even running test cases. So why does agentic AI matter? It comes down to four key factors: efficiency, scalability, adaptability, and intelligence. Efficiency, basically, agentic AI automates complex tasks without needing constant human oversight. It analyzes data, it makes decisions, and takes actions, which eventually saves time and resources. Scalability, unlike human teams, AI agents can handle thousands of tasks simultaneously with consistent quality. Whether it's managing customer queries or financial trades, agentic AI delivers at scale without breaking a sweat. Adaptability, it markets shift, customer behavior changes, but agentic AI adjusts in real time. It analyzes new patterns and it approaches to stay effective even when conditions change. For the intelligence part, agentic AI doesn't just follow instructions, it learns. It improves with each interaction, refining its decision making and becoming smarter over time. The next part of our slides are key components of agentic AI. So the first component which we are going to say is goal setting. It all starts with setting clear goals. Agentic AI needs a defined objective to operate effectively. It breaks down big, complex goals into smaller, manageable tasks. It's like setting a roadmap. If the goal is to increase customer satisfaction, the AI might create tasks like improving response time, personalizing recommendations, and analyzing customer feedback. By structuring the goal this way, the AI ensures that every action is aligned with the bigger picture. The next step, the next component is perception and data ingestion. Next, the AI needs to understand the world around it. Agentic AI gathers and processes real-time data from multiple sources, structured data like databases and spreadsheets, and unstructured data like customer emails, social media posts, and images. It makes sense of this data and processes it into a format it can work with. For the example part, it's like handling customer services. Uh, it could analyze both customer complaints and order histories to get a complete picture before deciding the best course of action. The third component is decision making. Once the data is in, the AI decides what to do next. As we have discussed, this is where it goes different from traditional AI. So, decision making portion, it evaluates different options, weighs the risk and benefit, and chooses the best strategy. What makes agentic AI powerful is its ability to handle uncertainty and to adapt itself to the changing conditions. It can make informed decisions even when not all the facts are available. And the next component of agentic AI is action execution. So agentic AI doesn't wait for human input. It executes multi-step workflows automatically, handling complex tasks from start to finish. Let me give you an example. For example, if it's a trading AI, it won't just recommend a stock. It will place the trade, monitor the market, and adjust the strategy in real time if needed. The most important portion of agentic AI, the next component, is feedback loop. After executing a task, it evaluates the outcome. Did it work? Could it have been better? It analyzes performance data and adjusts its strategies according to the required outcome. And then this continuous learning process allows agentic AI to get smarter over time, constantly evolving to handle new challenges more effectively. This is how our agentic AI works. We have input, processing, action, and feedback. So it collects environment data from different sources like sensors, APIs. We have external tools too, like CRM databases, and it also works in historical and real-time information. So the next portion is processing. Once the data is collected, the AI processes it to figure out the next steps. It analyzes the data using machine learning models to identify patterns and insights, and it then sets the goals, what is required and what it is not supposed to do. Finally, it chooses the most effective strategy to achieve the desired outcome. For example, if the customer is dissatisfied, the AI might identify that offering a discount or a product replacement is the best way to retain them. Then comes the action, and it can directly execute tasks using connected tools and platforms. It automates the process through APIs or system calls without needing human input. Uh, in our customer service example, the AI could automatically process a refund or send a discount code, saving time and improving customer satisfaction. Feedback, then comes the feedback again. So it collects the outcome of the action and analyzes the results using reinforcement learning or other adaptive models. It updates its strategy for the future tasks. And so for our customer service example, if the refund strategy increases customer retention, the AI will adjust its future responses to prioritize that approach. This was all about our agentic AI. So this session is all about agentic AI using Creo AI. So what is Creo AI? Creo AI is a framework for building and managing multi-agent systems. So we have different kinds of agentic AI. We have different kinds of agents. So multi-agent systems are one of the kind where multiple agents come together for a desired outcome. So this is a Python framework for building multi-agent AI systems. So For example, if I explain this using an example, so imagine you are running an e-commerce platform with free AI. So one agent can handle product recommendations, another can manage customer support using chatbot, a third can track inventory and logistics to ensure items are always in stock. So this was where different agents were assigned with different tasks, and these all agents come together to perform a required goal or to uh, get a required goal. So these agents can work together seamlessly, improving customer experience and streamlining operations. How crews work? As the name, the crew AI, the crew, it suggests that it is basically a collection of multiple people. So crew AI is collection of multiple agents. So the main structure of crews in crew AI work as follows. We have crew, we have agents, we have process, and we have tasks. A crew is the top level entity that manages the overall workflow. It manages the agents are assigned with the roles and responsibilities that we need that we need to attain the required objective. Think of it like a project manager that assigns and oversees tasks. So, crew is a collection of multiple agents. For example, if I explain this with an example, we have a financial trading crew which has uh, market analysis, strategy execution, and compliance checks. So the second comes our agents. Our agents are entities within the crew, which are designed to perform specific roles based on their capabilities. Agents can use tools like LLMs and APIs to complete tasks. Basically, we need to fit in data, we need to put in input into the agents to get the desired result. For example, in the same example, in the financial trading crew, a market data analyst agent would analyze market trends, a strategy developer would create a trading plan. When we have the process, a process defines how agents work. It can be hierarchical, it can be sequential. So in the market data analyst, for example, in the same example as I gave before, a market data analyst agent processes data, sends insights to the strategy developer agent. So this can be an example of a sequential process. So this can be either hierarchical, where one agent is supposed to delegate tasks to multiple agents. So the next comes our task. These tasks are the responsibilities which are given to each of the agents. And for example, the task of calculating risk or the task of collecting market trends across the market are, are assigned to particular agents like strategy developer agent or like market trend analyzer agents. This is the main workflow of how our tools work in Crew AI. So in Crew AI, we have agents where the LLMs are attached to each of the agents. We can also use APIs to collect multiple data for them. And we have somewhat memory attached to them, which keeps a check on what needs to be stored and what needs to be passed to the next agents. We have tools attached to each of the agents. We'll be learning about this in further slides. And each of the agents is connected, each of the agent is assigned a particular task, and therefore these all combine together to give a final outcome. So we come to the core components of the Crew AI, as we have discussed earlier, that we'll be starting with agents. So agents are the heart of Crew AI. They when we assign the roles and responsibilities to agents, we have to assign key attributes to each of the agents. So we have roles, we have goals, we have backstory, tools, and LLMs. Tools are tools we'll be learning after this. LLMs are you can use any large language models which we need for the agent. We can use GPT-4, we can use Claude. Trio AI supports multiple LLM models, and the roles are the title and responsibilities which the agent needs to perform. Then we have goal, which is the final outcome which the agent needs to serve. Then we have backstory. This is basically a description which we need to provide to the agent. It is like it can be for example, if I am supposed to give a backstory to an agent, for example, we have market data analyst, so we can give it like you are a market data analyst from 5 to 10 years, and you are working for this company, and etc. etc. So we need to design our agent strategically. We need to identify roles. We need to define attributes. The attributes which we talked earlier. These are some of the attributes. We have more of them, and we need to match LLMs to each of them to match our requirements. This is an example of agent which we have already created in Python. So this is hiring. This is an example of hiring crew. So we have two agents here, which are recruiter agent and outreach agent. See how we have assigned role, goals, backstory, and we have used allow delegation and verbose too. So role is the title and responsibility for the recruiter agent, which is recruiter. We have assigned goals. This is the final outcome which the agent is supposed to provide with. And we have also provided the backstory to the agent. So as we discussed earlier, the backstory is a descriptive backstory given to the agent. So allow delegation basically sets that the agent is supposed to delegate tasks to next agent or not. And then we have verbose. Verbose keeps a track of what information is being collected at each of the steps. So this is an example of a crew. Then the component is task. Tasks are the building blocks. These are attached to, these are assigned to all of the agents, and they provide detailed instructions and the context to guide agents' actions. And we have single tasks which are delegated to each of the agents. So this also contains attributes like description, which is detailed instructions, and we have agent to which the task is delegated to. We have context. This is an example of the task which we have created for the hiring crew, and we have candidate profiling task, which conducts the analysis of what the candidate has done and whether it suits to the role or not, and it keeps a check on and researches whether the candidate is suitable for the role or not. And we have also set the expected output, that what the agent is supposed to, this task is supposed to provide the results. We have delegated the tools to, for example, file read tool and search tool. Then we have agents which the task is delegated to. For the outreaching agent, we have candidate outreach task, and this is the description and expected output to use an agent for that. Then we have core components. Third portion, which is tools. So along with agents and tasks, we need external tools which are assigned to the agents. For example, we are creating a coding crew, so we need a Python interpreter tool which needs to be attached to each of the agents so that it can write and check the code. So the external tools can be calculators, databases, or interpreters, or any of the tools which are required for agents to perform their tasks. This is how we come to the final creation and running of the crew. So while creating crew, we need to define agents, we need to define tasks, and we have set the verbose as true, and we have set the memory as true. So we have also given the inputs, and then we have used the kickoff function to set to run our crew. So we have come to the end of this session, and we are open for the Q&A. You can post your questions in the chat itself. Yeah, we'll be sharing the slides after this session. You can go through them after the session. And you can also watch our recording on YouTube channel, which is Rabbit AI. We will be pinning the link of the YouTube in the chat, in the group. For the question, how does Creo AI ensure low latency decision making for time sensitive applications like drones and autonomous vehicles? These agents, actually what Creo AI ensures low latency decision making by using distributed AI agents. So these agents process data in parallel. These agents collaborate in real time, enabling faster computation and immediate responses. So for the low latency decision making, it can use distributed AI agents. No, you can use Creo AI for free as it is a Python framework, so you can use it in Colab itself. You can use the enterprise version, which is paid. For the Creo, how does Creo AI ensures low latency? Is the question, is the answer clear? Thank you, Safi. Are there any other questions, or we can move forward? We have something interesting after this. I guess there are no further questions. Before the exciting part, we have an announcement. We are having our AI Agents Bootcamp from 5th to 6th April. We will be pinning the link in the community, and you can just go and register for the bootcamp. Here we will be building AI agents from scratch, and this is an opportunity that you can miss. Just go and register for it.